right, we're going over questions on this approximating definite integral packet. Technically, you guys are supposed to have it attempted by the Thursday before break. You had a little bit of grace in that we didn't go over it because there were too many logistics to talk about. What does it mean, approximating definite intervals? What kind of stuff was in this packet? Riemann sums. Whenever you see Riemann sums, you should think base times height, right? Your forever cards, whether you wrote them or whether you quoted them. Base, how do we find bases? Change in x's or t's or whatever the independent variable is. How do we find heights? Function values. Function values. Now, if you're in a table, and it's a left Riemann sum for each little subinterval, I could go back to, let's see, here's one. Right? If it was a left Riemann approximation, you would find the base by going from one x value to another x value, or one t value to another t value. And if it was a left Riemann sum, what will we choose as our height? Our base is 8, but what's our height? 34, the one on the left. For that jump, you would choose the height or the y on the left. Hence why we have 8 times 34. The next jump, it's a base of 3 because the distance is 3. And we would choose, once again, the one on the left. What changes when we're doing right? Base of 8, but we choose the height on the right instead. If it was a midpoint, you would make a jump, and what would be in between? Another point. You would still make a jump, but there'd be another point in between, so you would have a jump over, or including 3 points, and you would choose the height in the middle. It would be given to you. So left, right, midpoint. Trapezoid, is that something that might show up?
Yes.
Yep. What's the area of a trapezoid?
1/2 base times height 1 plus 3.
Hey, some of you guys were cold soft writing. How many of you guys did right and you're like, I think it helped?
I wrote one of them and died.
Yeah. Jeremy showed me his this morning. He was like, I did everything 5 times. And I was like, his hand is going. But, yeah, the first 2 were long ones. All right, kiddos. What questions do we have? I do have a few circled from Thursday. I'm not sure if you guys have the same questions still. But what questions do we have? Anything? One. Okay, that one's still circled. Anything else? I have number 7 circled. 2? You have to speak loud because this ear I can't hear anything out of it. Like it's totally just. I have 1 and 2. Okay. Of the first one? D. Okay, yeah, I still have that one.
Number 7.
The non-calculator, right?
Yeah.
Yeah. Okay, I got that.
C on the first FRQ for this portion.
Okay. C and D. All right, I think we have enough right now, so let's go ahead and get going, okay? Number 1. Remember, you can have a colored pen out, you can have a pencil out. All right, 5 midpoint rectangles. Kiddos, what's the change, or I should say, what's the base going to be if we need to make 5 rectangles in between 1 and 11? Base of 11. Yeah, you can think in between 1 and 11 is a distance of 10, and 10 divided by 2, I am going to be going by 5s. Remember, you can do the 11 minus 1, find a distance of 10, cut it in fifths. No. 10 divided by 5 is 2. There you go. That's fun. Okay. So we have bases of 2. Let's see. Letter A doesn't even have a 2 times in any of it, so let's forget him, right? The rest of them have a 2 times. All right. Now we need to figure out our heights. For our heights, if you want to think about a number line, that helps a little bit. I'm going between 1 and 11. And I'm going by 2, so I'm going to go to 3, I'm going to go to 5, I'm going to go to 7, I'm going to go to 9. So these are my jumps, if you want to think about it this way. There's the first subinterval, second subinterval, third subinterval, fourth subinterval, fifth subinterval. But kiddos, if I'm doing a midpoint approximation, am I using, well, I just totally changed pages. If I'm doing midpoints, am I using, for the first subinterval, am I using the 1 to find the height, like f of 1? Am I using the 3 to find the height, f of 3? Or am I using the middle, f of 2? The middle, I'm using f of 2, because it's a midpoint approximation. So you have to think about, we're going to be using 2, 4, 6, 8, 10. And I'm saying we're using those numbers because we need to still plug them into, for our heights, our function values. We should do f of x sub star, or f of x star. So it just depends on the special x's. We're going to plug in 2 and 4 and 6 and 8 and 10. Because then when we think about f of x, we have to look at our function and say, hey, square root of. So we're going to do square root of 2, square root of 4, square root of 6, square root of 8, square root of 10. Which one is representing that? Letter B. All the rest of them use like 3 and 5 and 7. They're using the odd numbers. That's wrong. That's the only one that uses the even numbers and has base times height. Wait a minute. I don't see a square root of 4. It's 2. They just simplified. We had a question on number 2. This one is asking you to estimate a definite integral. If this is the graph of, which they say it is, if this is the graph of y equals f of x, kiddos, how do we visualize, how do we think about an integral of f? Area under. It's not a geometric shape, is it? It's not a geometric shape. How are we supposed to know what the area is? Wait a minute, did they say find it or did they say approximate? Yeah, they find it. They say estimate. So what can we know? Isn't this just a rectangle, guys? And what's the base of this rectangle? 1. What's the height of the rectangle? 5. Well, what's 1 times 5? All right, how many of these do we have? 5, 10, 15, 20, 25. Okay, there's 25. And then 30, 35, 40, 45. 50, 55, 60, 65. What else do we have? That's almost another one. We could do like him with him, 65, that'd be 70. Maybe those two, 75, maybe these ones. A little bit over 80-ish. Oh, let's see. Does that match up? So if they say approximate, the only thing we can do is figure out a geometric figure in there. Maybe you could have done like, I don't know, a big old rectangle and a triangle. You could always just find one of the little pieces or the little units and then just see how many of them there are. Okay, now number 7. A right Riemann sum with 2 equal subdivisions. All right, this was a little bit harder. Base equals delta x equals, I see my bounds are pi minus pi over 2. So I do my b minus my a all over how many equal subdivisions I'm making. 1 pi minus half pi is half pi. Half pi divided by 2 is a fourth pi. So we're going by pi over 4s. If it helps you, you can make a little number line. You can say I'm going from pi over 2 to pi. I'm cutting it in half, and that's going to be 1/4 pi over, which means 3/4 pi. Think you have to add a fourth of a pi to the beginning. Add a fourth of a pi. So we have our 2 subintervals. So right now I know my base. You guys need to see it set up. My base is pi over 4. Height. Okay, so for the first subinterval, kiddos, as I go from pi over 2 to 3 pi over 4, which I knew was my jump, because I need to go pi over 4, 1/4 north. Am I going to use pi over 2 to plug in for my height, or 3 pi over 4 if it's a right Riemann sum? Yeah, the one on the right. So I'm going to use for the first one, 3 pi over 4. So I can literally, if you want, just so you don't forget, you can plug it in to your function. So sine of 3 pi over 4. And then what am I going to use for my next subinterval, for my next jump? So we did the first jump, and we did 3 pi over 4 as our plugging in. Then for our next jump, what are we plugging in? Pi. So we can go ahead and sine of pi. Oh, stink. They didn't write sine, they used the unit circle. Hopefully you were studying the unit circle as you studied your forever cards. Sine of 3 pi over 4 ends up being Yeah, good. Pi over 4 times root 2 over 2. And sine of pi ends up being 0. So which one has a root 2 over 2 and a 0 when you add these two together? Because remember, you're just adding each. So this is why they're factoring out, this is why there's a pi over 4 in front, because they're factoring out the common base, and they're saying him plus him. Okay, time for FRQ questions. Let's go to the first FRQ, non-drafting calculator, C and D. We have a table, and in our table we have, let's see, time, velocity, and acceleration. Time, velocity, and acceleration. Okay, for letter C. Using a left sum and 5 intervals. So go from 0 to 12 in 5 intervals. Is that how you naturally would jump? 1, 2, 3, 4, 5. Oh yeah, okay, that's good. So 5 intervals approximate 0 to 12 of A of t. What is the true value? Okay, so we're going to approximate first. We're going to approximate using a left sum. So kiddos, on our first jump, I'm going to highlight it. 0 to 2, what's my base? 2, because it's the change in x's. So I have 2 times, what am I going to use as my height? 1. Why am I going to use 1? Because it's of acceleration, so I'm looking at the acceleration values, and when I'm choosing between the one on the left and the one on the right, I look and I say the one on the, so I'm going to use 1. 2 times 1. Plus, so we did our jump from 0 to 2, and we chose 1. Our next jump is 2 to 5, and we're going to use 3, right? So from 2 to 5, that should be a distance of 3. We're using the one on the left, which is 3. From 5 to 6, distance of 1, we're using the one on the left, which is 2. We keep going, 4 and 4, and then 2 and 1. Let me check it. 6 to 10 is 4, and we're using the one on the left, which is 4. 10 to 12 is 2, and the one on the left is 1. Do you guys agree? Yes. Are you going to try to simplify that and waste time and maybe get it wrong?
Yeah.
No. The question, kiddos, what would the units be of this expression? If I integrate acceleration, what am I going back to?
Velocity.
Velocity. And what's my velocity measurement?
Meters per second.
Got it. Now, the true value, they did not give you a function for A of t, so how on earth can they expect you to actually solve this? What's the antiderivative of acceleration? If you go back one, when we get to velocity. So doesn't FTC tell me antiderivative of b minus antiderivative of a is the actual integral? Oh, well isn't v of 12 in my table? V of 12 is 30. V of 0 is 0. That's a hard connection to make. That's a very hard connection to make. Because they're giving you all these values. They're asking you for an integral. You're like, I don't have a function. I can't actually find it unless you attach weight. Antiderivative of b minus antiderivative of a is in the table. I can use it. Letter D. Explain why must. As soon as I say must, I say it's a theorem. IVT or MVT? Almost always. IVT or MVT? It's not rolls, because that's a number, not a 0. Okay, IVT says, look at acceleration. Can you tell? Is there a number below a half and above a half? Can you tell from just the values that it's going to have to hit a half? Well, from 1 to 3, well, no. A half isn't guaranteed. It's not guaranteed, not guaranteed, not guaranteed. There's no number lower than a half, so I can't tell that it's going to have to pass through 1/2. Well, okay, IVT's out. So MVT. MVT, you need an A and a B. What'd they give you? an A and a B. And MBT tells us about a derivative looking at an original. So if we're trying to see if acceleration has to be 1/2, who are we actually looking at? Velocity. So we can say V prime of t, which is acceleration, must equal, on the interval 2 to 6, v of 6 minus v of 2 all over 6 minus 2. Now guys, I'm going on faith, but they gave me 2 and 6 for a reason, and IVT didn't work, so MVT must. I'm using f prime has to equal f of b minus f of a all over b minus a. I'm going to my table. V of 6 is 6, right? V of 2 is 4. And 6 minus 2 is 4. What's 2 over 4? So I can say by MVT, since V, let's see, a function has to be continuous and differentiable, right? And motion always is continuous and differentiable. 1, 2 to 6. And we can sound really smart just by using their wording. Acceleration must be 1/2 for some value. You're like, where's your work? It's right there. I proved it. Dun, 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 dun. Yeah.
Why do you use velocity?
Because acceleration, if I can't use IVT says look at all the accelerations and see if it has to hit 1/2. MVT says look at the antiderivative, look at velocity, and find the average rate. So you had to connect acceleration is v prime, and v prime I can tell from f of b minus f of a over b minus a. Does that make sense? All right, I think the only other question you guys had was FRQ number 2. Oh, no, sorry. This is a graphing question. This is a graphing question. You guys can kind of tell what they're asking though, right? An approximation from the left, from the right, trapezoidal and midpoint. Which ones are higher, which ones are lower? You don't have to know the numbers, you don't have to solve for them, you just have to figure out who's going to be bigger, who's going to be smaller. Okay, those are a few different ways of doing this, but if you come from the left, sometimes I start in the middle because it's kind of easier for me to see. If you come from the left, you're going to hit and then you're going to go out. So you're going to hit at all the lefts. Oh, that's not even going to be one because you stop at the one. And then the left. Okay. So right now the left is pretty low. He seems like a low one. If I were to go from the right, let me go ahead and red underline the left. If I was to go from the right, I would go up at 3, and I go over. Up at 2, go over. At 1, go over. Right now the right is definitely higher than the left. Well, wait a minute. The right is higher than the left. Hey, circle it, except. The question says which of the following is not true. Stink. Well, that is true. All right, we're eliminating. Not true. Make sure you read your question. All right. Trapezoid. I'll do green. Trapezoid, you hit at both heights and you connect. Hit at both heights and you connect. Hit at both heights and you connect. And right now, trapezoid is in between. Trapezoid is in between the left and the right. So trapezoid is lower than the right. Oh, that's true. Letter B is true. Anything more about trapezoid? Midpoint. This one's a little harder. Midpoint, you have to go ahead and find the middle between 0 and 1, go up and hit, and then extend. Find the middle, and extend. Find the middle, and extend. So the midpoint is definitely higher than the left, lower than the right. So midpoint is, let's see, midpoint is lower than the left? No. The left is the smallest one. Oh, so D's true. Sorry, D's the one that's not true. Because the midpoint is less than the right, that's true, so letter E gets crossed off, because the right is the highest out of all of those. Now you're between C and D, so you're like, stink, but it needs to be obviously false. The midpoint is lower than the left? Nah, the midpoint's above the left. So circle that one. The midpoint's not lower, the midpoint's higher. Okay, sorry, now we're on FRQ, and I think, yep, that's all we got. You have a table, one more time. Using your work from part A, stink. We're not going to do all the work from part A, which is the right Lehman sum, 5 subintervals. Let's see, 1, 2, 3, 4, 5. Oh, perfect. But what did you guys get for A, just so I can use it?
2.35.
Okay, 7 times my 35. And that was even, right? I'm not missing a decimal place. Okay. And technically, the integral from 0 to 12, going backwards to dollars, right? Okay. The average value of R over 0 to 12. Hey guys, forever card. What's the average value for me? 1 over. Now, average rate, F of B minus F of L over B minus A. Average value, 1 over B minus A. Integral from A to B. So, 1/12. Except, what am I going to do instead of the integral? Use the approximation from above. Dun, 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 dun. All you do is just take your integral that you solve for, I should say your Riemann sum, and just multiply it by 1/12. That's it. That's plugging into average value. Last but not least, letter D. Is this a calculator?
Yes.
Nice. They give us a function, and I'm hoping we can just put that function into our calculator. So the rate of change in the value of the stopping interval 0 to 12. For what value does the instantaneous rate of change equal the average? Guys, help me. You know this. Instantaneous rate of change. How do I find it? No. Instantaneous. Derivative. When you see instantaneous, you think derivative. So you need to translate. For what value of t does the instantaneous equal the average? What average? From 0 to 12. So the average value, wouldn't that just be q of 12 minus q of 0? All over 12 minus 0? Okay, how do we do this in our calculators? How do we have our calculators help us? What am I going to put into my calculators?
You'd put in the Q formula for Y1, and then you do it to the thing.
Because you can do y1 of 12 minus y1 of 0 all over 12 minus 0. Can't we do that in our calculator?
Yes.
Yeah.
And once we have that, can't we stow it and then make it like a y value?
Yes.
Okay. And once we stow it, I'm going to go ahead and clear this out real quick. If you guys have it, you're using your nifty fraction thing just to get everything in there, right? Now, I'm actually not going to graph this, kiddos, just because I don't care about Q of t besides using it for the formula. I am going to, actually, you know what? Maybe we could be snazzy. Let's see. Maybe we can just put in the average value into our calculator. Do you think? y1 of 12 and not even need to stow it, minus y1 of 0 all over, oh, all over 12 minus 0. Hopefully I can do that one in my head, right? Okay, so we have that guy ready to go. And I need to graph that guy with, here's the dealio. We need to go ahead and set the derivative equal to this number. I have the number in my grapher, but I don't want to set the original, I want to set the derivative. So then don't I need to find the derivative?
Yes.
Can my calculator find a derivative, a general derivative? So I have to go back to solving by hand. It's a little bit annoying. How am I going to find q prime of t? Quotient rule. So I'm going to do bottom, do top. All right, kiddos, you're almost there. You just need to hang in there a little bit longer. Minus top, d bottom. All over bottom squared. If you guys don't mind writing it in your calculator, you can just leave it like that. So I'm going to go on back. It's up to you as to how paranoid you are. You can go ahead and plug that thing into your calculator. If you want, you just plug in the quotient rule itself. You can do 30 times 1 plus x squared minus 2x times 30x. This is me being super paranoid, not wanting to mess anything up. All over 1 plus x squared squared. Do you guys agree with my quotient rule? Does it look good?
Yeah.
Yes.
Okay. I'm going to go ahead and go deselect my y1 because hopefully it doesn't take away my value. That would be kind of sad. I'm going to do zoom standard and we'll see. Oh, you know what, guys? Don't they tell us 0 to 12?
Yeah.
So we could always change our window to be 0 to 12. Maybe that would help just a little bit. All right. Haha! Do you guys see an intersection? I do. Yeah, I only see one. This is going to keep on skimming. I think it's the horizontal axis of the 0 now, which makes sense because it's the degree on the bottom wins. So we can go ahead and do second trace, intersect number 5, first second go. That's just something over there. There we go. 0.986. Were they asking for the time, right? Sweet. Kiddos, there's no other work you need to show. Did I round that correctly though?
Yeah. You did.
0.986. So we can just say. What are you not going to forget because I took off points on your AP if you didn't put it? Units. T is measured in this problem in days. Don't you let them. Alright, go ahead and pass this up. Actually, never mind. Just go pass it back. Go put it this way. If you guys want to put it in by the end of the day, technically I'll still take it and it should be done. We have 5 minutes. 5 minutes if there's some multiple choice from your AP corrections that you've just been killing you over break and you can't figure out how to do. Ask me one quick. Bridget, what's your question?
Can I put in when I finish eating?
Yeah. Yeah. Right, ask me. Yeah, which one for you? Number 7. Yeah, you can pass it up. All right, and then your guys' practice exam, let me go find number 7.
Oh, yeah.
If you guys want to go in your AP exam corrections, number 7 is what we're looking at. Hey kiddos, tomorrow we are starting right away with our AP mock exam corrections, so make sure you bring your mock exam tomorrow. Your AP mock exam corrections, we're starting now. Since we have no clue how to do it. Okay, total area between the curves from 1 to 3. Okay, now, they did tell me bounds from 1 to 3. Area, we need to think integration. However, we need to be careful and make sure there aren't any hidden intersections in between 1 and 3. So if I want to find area between, I need to make sure there are no intersections where the orientation switches and I get all messed up. So I'm gonna go ahead and solve for intersections. Let's see, add the 6x, I get 6x squared minus 12x equals 0. Uh-oh. You would have missed this if you didn't realize you needed to split the integral up at 2. There's a hidden intersection in the sense of in between 1 and 3 you have an intersection of 2 or at 2. And so we need to go ahead and in solving this problem do the integral from 1 to 2 of, if you don't care about what it looks like, remember you can use absolute value now that you've found your intersections. Minus a negative 6x would be plus 6x. Put little absolute value bars on the outside now that we've split it up. And then we can also go from 2 to 3. Once again, since the absolute value bars are there to help us, we can just do one curve minus the other. At this point, I would go ahead and say, hey, it's the same thing as 6x squared minus 12x. 6x squared minus 12x. When you're integrating x cubed over 3, that'd be 2x cubed. You can always double check both faster. Minus the derivative. Minus x squared over 2, 6x squared. From 1 to 2. Nice thing is the next one's going to be the exact same. 2 to 3. Guys, that'll get it for you. Guys, kind of plug and chug. Now some of you are like, ew, I don't like plugging and chugging. This is a non-calculator question. All right, cool kids. I'm circling it to show that we went over this one as a question. What are you coming with tomorrow in class? Correction questions. Does that make sense? Correction questions. Make sure you have your AP, the multiple choice, and the free response. And if you haven't yet looked online, the free responses 1 through 6 in your class share folder, AP exam practice. All the solutions are there. Sound good? All right. Good job. Way to stay awake, way to get in there. I'll be in here lunch and nutrition and after school, but I might be leaving fairly quickly.
Hit someone?
Bye guys.
Probably like they didn't get mad.